So, right, again, welcome, ladies and gentlemen. This is the talk that I used to give all over the place at the time, almost 20 years ago. Time goes very quickly, doesn't it? I came to Ireland in the latter part of 1978, and I actually started work at the company on January the 1st, 1979. And I left in April 82, I suppose. Seemed not very long at the time, but it's an awful long time ago now. So that's the world-famous logo. That's the name of the company that was just across the road here. Delorean Motor Cars Limited, wholly owned by Delorean Motor Company. Now, a lot of our transatlantic friends think of England as being a little island off the coast of Europe somewhere, whereas it's exactly the opposite to that. This is basically England. There is Ireland, and that's where Northern Ireland is in relation to Eire and England, and Scotland up the top here, of course, Wales there. Inside that area, where we were today, across the other side here, Dungannon, the other side of Lough Neagh, here's Belfast, and Dunmurry just down below. It's much easier to picture it in your mind, I think, if you see that sort of layout, with Strangford Lough there and Belfast Lough across the top. And to get into slightly more detail, Dunmurry, DMC there, Derryarchy here, Lisbon down below. And we used to take the cars down to the docks down there for shipment. There is the layout of the site, more or less as, well, definitely as planned at the time. You will no doubt have noticed that this road doesn't actually exist. Such is the way of town planners. It all seemed a good idea at the time, but it didn't actually happen. Twinbrook Estate up the top here, and the main factory here. This was the original building, which was a carpet factory before we moved into it. That became the training building and the initial sort of company, whilst the rest of it was going on. This was going to be the main office at one time. That actually didn't happen. But this happened, that happened, and a couple of other buildings here, which you can't even see on this layout. These buildings were much larger ultimately. The boiler house was there, the test track was there. I think some of you have seen that already, and you'll certainly see it tomorrow. Originally, the track, this whole situation looked much like that. That's the site with only the first bits of mud appearing on the site. It was a true greenfield site, as you can see. One of the delights of which was a river running down the middle here, which we had to move. There's the original building and the original entry there through Twinbrook. You'll have noticed that the later entry was through the bottom end here by the railway bridge, and that originally linked to the main Derryarchy Road, where it doesn't now. You have to go up through the industrial site. So that was the site, the original site, just the other side of the railway from here. There you see the site being developed, a huge amount of rock put onto the site. It was built up and levelled in areas as much as 4 feet of crushed granite down the bottom here, brought from the hills behind by lorry. The river was moved down the side here in a culvert, all laid out to keep it out of the way of the site. It never flooded, although I expected it to. One of the problems we didn't anticipate was snow. Never rains very much, and it never snows in Ireland, they said. It's a lovely mild climate. Grass grows 10 months in the year. No real difficulty, they said. And lo and behold, the first time I came here as an employee, I landed at Aldergrove, and 2 of my colleagues were there, one from California and one from Europe. The one from California was standing there in a floral shirt with his short sleeves on. I was reasonably well equipped. I had a raincoat on at least. And this is what we stepped out to. So never get snow in Northern Ireland. So no real problems. That's the next step in the build there. I haven't put every slide in, but here you see the buildings being constructed, roofing going on, the superstructure itself, all the RSJs and what have you being put up. You can see the general layout of the site there, the final prep building, the emissions laboratory and so on here, and the bottom end of the build shop. The body press shop, as we call it, the fiberglass shop, really not in existence yet. Quite a nice view of Twinbrook as it was then. Another nice view. You see here the body press shop. You see in front of it here the large storage tanks for resin and what have you for the fiberglass. You see the high area down the middle there, which was to carry the crane gantry system for moving the body tooling around inside. We had something like 17 sets of body tools so that we could interchange them and service them all the time. We also had to have quite a lot of them because the process time was quite slow, so we had to have a lot of them in operation at the time. I seem to think the process time was something of the order of 2 hours for those, so it's a really long time in mass production terms. Bodies were made in this shop, shipped sideways into that shop. We'll come to that in a little bit more detail in a minute. This shop also contained the goods receiving and stores. You see here the dock levelers. Goods were supplied, taken inside there through the inspection department inside. I don't know what the inspection department did, but they were there. So the goods came in here into the general stores inside, where it was fed to the track, which ran down the far side and back up here and out through these doors at the end. We mentioned the training building a bit earlier, and this was the layout of the training building, which also contained admin offices, of course. This was the layout. Originally, it contained everything to do with the company. Latterly, it turned into a real proper training shop. It also had a bit of engineering down in the bottom, such as it was, to look after special cars and do various modifications and developments. It also has offices at the front of the building, which were, again, admin offices. And upstairs there it had what we call the executive suite, which contained senior exec offices and what have you. Originally also there was a cinema arrangement down the bottom end here, which was originally the boardroom. The idea was that every incoming operative, was trained for a certain amount of time on every aspect, or the aspects he was particularly concerned with on the car. The idea was that each man should be familiar with all the operations, so we retained flexibility of staff, so they could be trained, they'd know what they were doing, they could move around on the production line. So everyone was supposed to be trained before they went on the production line. One of the big advantages of Northern Ireland from our point of view was that although there's a great tradition of engineering over here, it was at each side of automobiles, shall we say, shipbuilding on one side and aircraft on the other. So whilst you might say you're starting from scratch with engineers, people building cars, you didn't have to unlearn anything. They started clean. Whereas if you picked up a crowd in Coventry, for example, you'd have to teach, get rid of all their nasty little tricks before you started teaching them new stuff. So it was really training from scratch, hopefully quickly enough for them not to get into any bad habits. This was the layout of the body press building, as it says. It's an official slide at the time. It's a pretty lousy one. However, I'll just point out 3 tracks which are fairly obvious there and one longer one here. The body, i.e. the fiberglass hull, was made in that area. The construction system consisted of hand laying the fiberglass mat into tools, into dies, and injecting the resin, closing the 2 halves of the body together, allowing them to preset green, taking them through the oven so that they finish the cure, and then finally taking them through an oven to take off all the flash and what have you, excess material. Now the assembly building, you recall that the body press shop was that side there. So the bodies were lined up and brought, they were lined up through a 24-hour production ratio and pushed across here to keep the production line going. Of course, this process was a lot quicker than the body press shop process. So we stacked them up over there and brought them in here for the next day. We saw on one of the first slides the dock levelers here with the incoming materials. So you've got materials inspection, bought out parts storage, snack bars, and so on. And this lot was used to feed the line during the day. The idea was to do it overnight, in fact, but it didn't always work out like that. So they all fed the line there. We had the chassis line, the chassis dress line being fed from one of the other outside doors here. See that again in a moment. Came together there, body drop in this general area, a chassis drop onto the teller's carrier, body drop on top of it, and then round into picking up the doors and exterior panels. Finally here, which isn't shown, we had the rolling road to test the brakes, lights, steering and all that sort of thing, and to make sure it complied with the regulations. So emissions and vehicle preparation building. When the vehicles come off the end of the line, we were obliged to check a certain number of vehicles for exhaust emissions and such like. We checked as many as we can, provided that number is above the legal minimum, but we would check as many as we could. They would be checked here. There was an area in which the whole vehicle would be soaked for temperature for a given amount of time, day and a half, something like that, to make sure it was at a regulation temperature. They would then be properly checked for the whole emission cycle before they were put out for a sale. This area here was final preparation of all cars anyway, so a percentage of these would have gone through that anyway. So the cars came out of the main body assembly shop, which was up the top there, into this lot, through all this arrangement, and then finally pushed out, hopefully straight down to the docks. So part of the testing, of course, was to go around the track, and part of it also was to go through the water test. Okay? Now, as you all know, the bodies were made of fiberglass hull, using the VARI system, VARI, vacuum-assisted resin injection, which process Colin Chapman personally owned and had patented. It's a very good system, but it involved laying up the fiberglass chop mat into various tools. It obviously had to be cut to some sort of form before being laid into tools. And we started out by using lots of operators. You would notice 50% of them didn't wear goggles, safety goggles, although 100% of them should have done. We used these hand-made templates and cut the fiberglass out by hand also. Very laborious business. It was due to be automated. But that's how we started off. So each of the bits of fiberglass mat was cut out by hand prior to being laid into the tool. There's a bevy of them. They were obliged to wear goggles. You can see rather more there, 60% of them wearing them there. They're awkward to wear, but you only need one piece of glass in your eye, and you realize how valuable they are, because you can't get glass out very easily. Let it work out over a period. So you can see them cutting around the lines they've made with the templates. The fiberglass hulls were made up, as I briefly described, with fiberglass mat laid into a mold, but for stiffness, additional strength, beam strength and so on, we used beams. Now the beam itself didn't give the strength, it was the structure around the beam that gave the strength. So these beams are made out of polyurethane foam, semi-rigid polyurethane foam, in a mold. These are the operators cleaning them off, removing the flash lines and so on, prior to them being wrapped in fiberglass mat, which you can see them doing here. Or you might have to take my word for it. Yes, here we are. These are the rigid polyurethane, or semi-rigid polyurethane moldings, with the lads wrapping fiberglass around them and stapling them on prior to being placed in the mold. Now these are the molds I was talking about. We saw them on the first parts of the track in the body press building. So these are the molds. That's the bottom part, shall we say. This is one where the top part's been, that molding's been lifted out. But this would have a mating part which would drop into it and form the other side. It's a double-sided die, effectively. These are made out of epoxy resin with a filler and a steel frame. The top part of the die would close onto that when it's been loaded up. The hole would be subjected to a vacuum, and then resin introduced at various areas around it. Just the right amount so that it would fill in and form right to the edges. Not too much, else you scrap it, or you waste too much, I mean, and not too little, else you spoil the whole molding. Here you see them placing, if that's the right word for it, the fiberglass mat into the dies. We saw them cutting them out. They obviously have to be cut out into some quite complex forms so they fit in the right places, and they have to be fitted in the right manner. So there you have them doing it. You see the number of dies we've got coming through to maintain the production time cycles. That's it full. This is the top part of the die being prepared, ready to drop in. So that would form down inside with a bit of care to make sure that the fiberglass still lays in the right direction. The seal around the edge here would become tight around the edge of that before the vacuum is applied. In order to maintain the quality of the fiberglass resin mix, we used to have, rather primitive by current standards, a computer system to make sure that it was at the right temperature, it was used in the right chronological order, the incoming amounts. The storage tanks I referred to were kept at a constant temperature and constantly stirred to make sure the quality of the fiberglass as used was more or less constant, reasonably consistent within reasonable standards. So we used that to make sure that the quality of the fiberglass injection system was reasonably constant. Having injected the relevant quantity, then of course it's left for a certain amount of time in the mold for the thing to at least cure to the green condition. So this is it being lifted out. You can see the track rotating, as it were, around there, circulating. And that's what the bottom part of the hull looked like. That's still in the die, of course, before it's popped out and before anything's cut off. You'll notice the door apertures are full here, and the various holes in the floor are still there. They're left in at this stage to try and maintain the dimensional integrity of the chassis, of the body. You can see the other dies ready, all going around on the circuit. Having taken them off the machine, as it were, green, they stood for a while before they went into the oven, through which they passed relatively slowly. You can see the top part's been attached to the bottom part here. It was bonded, and we used a staple system to hold the two parts together. Quite simple, rather crude in some ways, but it was effective enough. The staples were only there to hold the things together while the bonding material went off.
You use resin?
Yes, we use resin bonding, epoxy adhesive. We tried all sorts, but so you can just see the excess oozing through there. So that was quite a long process again. Not really a mass production process unless you've got enough of it. Now here's the fettling bit where all the flash was taken off. You can see all these operators working here. It was a very labor-intensive system. It wasn't intended to be, but it turned out to be because we couldn't perfect automatic equipment in the time that I was with the company. We tried a lot of it. We had immense problems with tracking around the apertures. We had lots of problems with wear and so on. Eventually it came back to these individuals working in what I would consider to be a horrible environment, although they're all hooded and screened and what have you with their private air supplies and so on. And that was the situation, I should say, first thing in the morning, because you'd had all the day shift and possibly the night shift. And here was the stock of underbodies, hulls, whatever you like to call them, ready for the next day's production. At this stage, you've got the whole thing completely fettled with all the steel mounting brackets bonded to in the right places for the torsion bars, for the door locks and seatbelt mountings and engine mountings and so on and so forth. Naturally, the quality control side of it, the inspection side, would pull these off every now and again and check them all over for general integrity, dimensional integrity. One of the big problems with fiberglass is that tolerance variations can be up to ½ an inch. in the normal run of production. And that's extremely difficult if you're hanging a body onto it, which is going to be to 20 or 30 thou. And that meant that we had to make the body panels all individually adjustable, which led to enormous problems initially on production because everybody adjusted everything and they never actually fitted. So you go round and round in circles trying to make them fit. So eventually, with care, you can start in one place and work steadily out in all directions, and that's the best thing you can do. You've got a good accurate data, and the worst or the most difficult part is to get people to work to it. Because they love to adjust things. You know, that's the skill in adjusting things, and it takes forever. So, here is the end of the body press shop, with them all lined up ready to go. Across the gangway, you see actually we've got an overhead, that wasn't there originally, we built a tunnel across the top there to avoid blocking the roadway. And there is the beginning of the assembly shop. Right, let us move on. These are the panels as delivered. They were not formed on the site, of course. There's all stainless steel panels made down in the south of Ireland. They came in with plastic coverings on, Nitto sheet, which served two purposes. It protected the surface, which, as you all know, is a brushed stainless steel. It protected the surface. It also provided a lubricant within the die itself. Steel dies, of course, in this case. This is a hard material. It's quite difficult to press in some ways, and you have to adjust the clamping loads between the two parts of the die before you press. It's quite different to mild steel. It doesn't stretch and flow in the same way. But the benefit, the huge benefit of these materials, 306 was it, the alloy? I can't remember now. The huge benefit is that they don't corrode. And we've seen test samples that have been in a salt environment for 50 years. And you more or less have to clean it up, and it's perfect. There is no corrosion. The exhaust system is a different alloy. That's 409 alloy. And you'll see that that actually goes a sort of brownie color. And that's as far as it goes. Another side of the business was the preparation of the steel panels. You can see the preparation of panels here preparatory for joining them together. You will recall that the panels are clenched together where they have inner and outer panels, spot welded in some cases, but for the outer panels they're all clenched. You can't spot weld them because the spot welds show through. The bonnet was something that was bonded together also. But even the spot welded ones were in fact bonded before they, oh sorry, not spot welded, even the clenched ones were bonded before the panels were actually formed to hold the two in the right relative positions. These are body panels as brought into the factory. These are doors, of course. These would be laid into these individual tools, and the first part of the bend of the outside edge prepared prior to the laying in of the inside part of the door. You've got to start the bend somewhere, so the automatic machine you see in the background can then clench the panels together. These are door structures which go inside here, all pre-prepared. These are made up of various sections spot welded together. So these were the interior door panels pressed out of quite thick stainless. You get an impression of the thickness looking at that one, and spot welded together. One of the difficulties with gull-wing doors is not that of strength, but of stiffness. Now you will all know if you grab the front of your door and try and slam it, it jams. And before we put those wedges on the front, it used to take lumps out of the adjacent bit before it jammed, so you had a compound problem. But it's extremely difficult to make them stiff. And when you think that the hinges are only that far apart, and you've got an overhang right down to here, it's a very awkward job. It's a huge moment for a starter, and also you've got the weight in here, which makes other problems. The stainless steel torsion bar at the top there was very effective in holding the thing up. We did depend a little bit too much, I think, on the gas struts because they're temperature sensitive and the loading isn't always the same, as you will also realize. But the torsion bar itself was an interesting developed by Grumman in the States. The bars were I think 14 turns, 14 full twists in constructing those bars. They were twisted in liquid nitrogen, as far as I remember. And they actually got longer when they were twisted because the crystal structure altered. You'd expect them to get shorter. Okay, so let's move on from there a little bit. Further section of the jig structure, holding the panels, the substructure panels together in the door inner pieces we were talking about a moment ago. I don't seem to have the one clenching. These are doors which are finished in the steel construction going down the door assembly line. Now that was quite a long drawn out business. Each door was assembled individually, in pairs of course, prior to assembly onto the vehicle. So they're all pre-assembled and hung a little bit later in the process. This is the chassis delivery spot outside the factory. I might add that the chassis were originally intended to be stainless steel. The first prototypes built in America, the first 2 prototypes were made out of stainless steel, and quite a lot of the first prototypes made at Lotus were stainless steel. But at the end of the day, we got cold feet on it in view of the penchant that the Americans have for litigation, because at temperatures below 0, it had an unfortunate way of cracking in the case of severe accidents. So we went, as you know, to a mild steel with an epoxy finish. So the chassis were delivered in batches like this on stillages ready to come into the factory. These are the chassis, as you can see, when they've been first brought into the plant. So you can see them here, this operator, just running a tap into the various holes, the tapped holes. One of the biggest problems you can have with a chassis, however you do it, is whatever finish you put on it getting into holes. Now we looked at all sorts of ways of doing this, having gone off the stainless steel, not least of which was zinc plating, which is a lovely finish and it stops it going rusty. Second almost to none in its effect. However, it fills holes up, also second to none. So we didn't go that way. We went for this epoxy finish where we heated the steel chassis and dropped it into liquefied powder, basically. And well, the chassis was hot, so it melted the adjacent powder to it, and it formed a nice hard finish, semi-hard finish, I should say. It wasn't really hard. And here you see the fuel tank protection plate going on underneath the chassis. That being the back of the chassis, this being the front, of course. Now then, these were where the chassis were taken off the chassis build line prior to being dropped onto Tellus carriers, prior to having the body dropped onto them. These are the famous Tellus carriers, which gave me several heart attacks over the period. They were supposed to stop before they got to you, but they had this very unnerving way of stopping and making little darts at you. And knowing that they could chop you off smartly at the knee, it was a bit of a pain. But these followed a track in the floor, of course. It was one of the first large-scale uses of these things, and they were very successful, actually. We could plot them round, we could park them, bring them in as and when required. So it was a very satisfactory way of doing it. The chassis came into the factory on in a separate point, into the main assembly shop, and we saw somebody on a slide or two back preparing the holes in the chassis, preparatory for assembly of the various subcomponents. These were assembled on a separate track. The engine, we had engine dress feeding this track. This was chassis build line, which itself made its way up to the body assembly track. Another view of the same track. Here you see the complete chassis, virtually finished, working from the front with the radiator and so on, suspension, fuel tank, right the way back to the engine and so on and so forth, the gearbox, rear suspension and so on. Almost ready there for body drop. So that's on a Tellus carrier, yes, all ready to move around the factory. This is the beginning of the body assembly track with the body straight out of the panel shop, sorry, old habits die hard, straight out of the body press shop, ready for general assembly with a root card on it and build sheet and so on. Here you see it on the track, being prepared, various sections cut out. These were wood, I don't know whether they were all the way through the period, being fitted in, cut to shape, various bits being fitted around the car, as you can see there, various bits lying on the floor ready to be fitted. I always show this one and to demonstrate that we did have girls on the line. You wouldn't know nowadays with the hair, but in those days it was a bit more obvious. You have to lift their tails up to find out, as they said. So that's the beginning of the body assembly line. That's further proof. That wasn't set up. They actually did work on the track. Car being steadily assembled prior to mating with the chassis. There's another view of the track, again looking from the body press shop end. Here's the moving track. These are the stores come up from the general store there for assembly onto the car. Further down here we had the chassis build line and the door build line. Beginning to look more like a car at this stage, although bear in mind it has no chassis still. Now, here you have a Tellus carrier with a chassis on it and the body hovering over the top. So this is the body drop area. More or less complete as far as it goes. Those two would then be brought together prior to moving into the body paneling area. There's a further stage in the body drop. Body almost in contact with its eventual chassis. Here you have the bonnet assembly, which is one of the areas which I said was bonded. At this stage, we bonded the whole of the cruciform to the inside of the panel. You can see one lying on top of a fixture there. So here you have the final part of the assembly, as it were, with the doors beginning to be assembled in position. You recall I was talking about the amount of adjustment available on panels, which was a nuisance. Really, the starting point was the center of the roof. Get that in the right place in relation to the chassis, and everything else should go well. So you start with the central panel there, the central heavy steel hinge member, and the panel over the top of it, and the two doors. And then all the other panels could be fitted to it, and the clearance is adjusted. The famous torsion bars, which everybody's so fond of. The next stage, more panels going into position, hopefully in the right places. Don't forget they have to fit at both ends, which makes life pretty complicated. They've got to fit the bumper, or the polyurethane assembly at each end, which in itself has quite a big tolerance variation. So you have all these things adding up. I expect they're struggling and swearing at it there, but that's just a further stage in the move, although that's moved quite a long way forward because it's got its wheels. So that's right at the bottom end of the production line. The vehicle is almost ready to be taken off the Tellus carrier, and the Tellus carrier sent back on its way. We talked about repair of panels earlier on, and these are a couple of slides that I put together to illustrate really how easy it is to repair the panels. It is not very much more difficult than standard repair of ordinary steel panels. Here we had dented one. To some degree you can get it out in conventional way by heating and cooling it and coaxing it out. You can also hammer it out, and then you see we're working on it here with levers and hammers and so on. Reproducing the finish at the end of the day is probably the worst problem, as we said earlier. We used what we called Engis wheels, which are flap wheels, abrasive pads, which were pretty satisfactory. It's very difficult to get them going in the right direction, as Alan was saying earlier. Also, it is very obvious if you're not careful. In a sense, you end up doing the whole panel, rather like you do with a metallic paint. You have to blow it in for the whole lot so that you can't see the join. But whatever you do, you don't use metallic things. You use Scotch-Brite or something like that. I should say an abrasive pad, shouldn't I, really? So here we are, further work on it. It is just generally to illustrate that Normal working practices, normal situation will or can be applied to repair the panels. It's not difficult. There's the aforementioned Angus wheel. We tried all sorts of different ones, all sorts of different diameters and sizes and speeds and so on. And it all worked out very well eventually. We were able to reproduce a quite satisfactory finish, and you couldn't see the join, as it were. So we've come off the end of the production line now. That is, to all intents and purposes, a complete running car. It hasn't got the back end on, but it is a complete motoring vehicle. So it's gone onto the rollers here. Did we have 2 rolling roads? Yes, we should have done, yes. I know we started with one for a good period until production built up. The driver would sit in here and effectively drive it, following the instructions on the screen there, just as we do nowadays on emission testing and such like. So he would test the operation of all the lights, the brakes, we didn't do the emissions here, but all the usual bits and pieces around the car. And that is just before the final door out of that building. This is a picture of the setup in the emission laboratory. I don't know how many of you have been in an emission lab, but they all look roughly the same. Run the car on rollers. The rollers have their own inertia setting so that they're roughly equivalent to the car inertia, so that you can drive as closely as possible to the normal road driving and measure the exhaust coming out as a result. You also do the economy testing there, which is part of the system and quite critical, of course. Exhaust taken out, fed through various extractors into the analysis laboratory on the far side there. So one of the things that we were very conscious of is rainwater ingress. And we had installed these spray booths outside with high-pressure water jets, which were very, very effective at getting water inside the car. If you could stop that lot going in, you were doing pretty well. We had that in addition to the water splash, of course, which I'm not sure whether it's illustrated here, but you've seen it down beside the test track there. We had lots of fun originally with panels not really being in the right places and seals not working properly. It's a tremendous problem, but we very soon got over it, actually. I don't think production cars suffered with the problem for very long, at any rate. Now there's the test track. There is the water test, the spray booths that we just saw. We also had a water test about here somewhere. Is it behind the trees there? Just there, because we used to come around the track and run straight through it. That was a hard pavé section, as far as I remember. So we could do both the static testing there, with spraying water in all directions, and the, as it were, puddle testing down this side, where you got all the water from underneath. That is the banking that should have been 70 miles per hour, but turned out to be about 50 at the end of the day. We had down here some hard ripple section, principally to shake and rattle the car, so we could be sure it was reasonably rattle-free when it went to the customers. And the idea was that it was down the middle, so you could run the right-hand side or left-hand side down it. Nice picture of the interior as they started out. These ripples were all molded in, of course. You appreciate that. Took a lot of research to get the right effect on that, or what they thought was the right effect. Another picture of the interior in pristine form. Interesting to see the gas strut there. You can see again the pre-molded form of the seat squab there. You can also see the split line between the leather and the plastic. And there we have the finished car over at Castle Ward, in fact, at the bottom of Strangford Lough. Quite a nice picture, I always thought. That's why I showed that one. Another picture of the same car in the same place, alongside the sawmill, I think that was at the time. Just another nice picture. That's looking out over Strangford Lough down the bottom end there, with, I suppose that's Portaferry in the background. If you've not been down there, it's a delightful part of the country. You ought to go before you go back. There we are. Thank you very much.